All right, so I think that this is working. Good morning or afternoon or evening, depending on when you get to this assignment. Um, just want to say welcome. This is the start of a new week. This is kind of the official start of phase 2 of this distance learning. And so I really wanted to kind of emphasize this visual, right? You're going to see me at least once a week in some form via video, whether it be on Zoom or um, in a recording like this that you guys watch. And today we're going to have some notes on the law of sines. And I thought it would be perfect for us to go through this. So I've got my iPad pulled up and we're going to be doing some notes. And you're going to be following along with me, filling out your notes, and I'm going to have you turn those in when you are done. So this will be your assignment today. So if you have not done so already, download the note sheet from the Moodle assignment. I have posted the link to that Moodle assignment on our office hours Google document. And I would like you guys to either print off the note sheet or take notes in the same order like what we do on a separate sheet if you don't have a printer. That is absolutely okay. And if you'd actually prefer to do it that way rather than printing off a note sheet, just because it's easier that way, go for it. Do not I can't talk. It's Monday morning. Well, it's actually Sunday night when I'm making this, but I can't talk. So it does not matter to me. It's a-okay. So this new and this new concept is dealing with triangles still. So you were just practicing last week how to find a side length or an angle of a right triangle in order to find the missing pieces in that triangle when not all the side lengths and not all the angles were given to you. And there were these things called sine, cosine, and tangent. Those are trig functions, and you were using those in order to find the missing sides, missing angles. Now, we're shifting into an area where we're still going to use sine and we're still going to use cosine, but tangent's going to kind of drop off for a little bit. But we're going to have a new way to use sine, that trig function sine. Now, before we continue, I'm going to take my camera off, I believe, if I'm able to. Hopefully that disappears. I'm not sure how that all works, but anyways, we are shifting to law of sines. And the law of sines is this fancy law or formula or just property that we can use to find missing pieces. But notice that this triangle is I want to be able to draw in here. Oh, there we go. This triangle is not a right triangle. So none of these angles are right angles on this triangle. And so what I'm trying to figure out is there a way, I can't use SOHCAHTOA, right? So before we used SOHCAHTOA, right? Sine is the opposite over the adjacent, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. That is not going to work for us. We cannot use that. So I'm just going to get rid of that altogether. But anyway, so this law of sines, we can use it in two ways. And the law of sines is basically stating that if I were to, oops, my bad. If I really wanted to try to find a side length here, there's this equality, which is why I have equal signs here and here, here and here. There's this equality that allows me, sorry, I'm kind of navigating this technology, but there is a law that allows me to state some equivalences and then use my known information to find my unknown piece, just like with SOHCAHTOA. With SOHCAHTOA, they always gave you 3 pieces you know and 1 you don't know. Or two pieces you know and a third that you don't know. Sorry, excuse me, that was wrong. In the law of sines, they're going to give you three pieces, and you are going to have to find the fourth missing piece. Now, what the law of sines is, when we're trying to find a side length, if we're trying to find a side length of one of these triangles here, here is the law of sines. Now, this is going to be something that you're going to have to memorize, just like we did with the quadratic formula. But the law of sines states that the side length A, let me rewrite that. Side length A divided by the sine of angle A is equal to side length B divided by the sine of B. And that's also equal to side length C divided by the sine of C. So we're only using the trig function sine. Now, the reason I have A and A, B and B, C and C is because they are opposite of each other, right? So little a is opposite of angle A, C is opposite of C, and B is opposite of B, right? We're just talking about all these opposite angles at this point. And this is going to help us solve for these missing pieces when they give us three and we're trying to find one. So we're not going to look at this yet. We'll come back to that probably on Thursday. And you will continue and fill out these notes the rest of the way. So let's try an example. The best way to really learn this is just to try it. But this is our equivalence, and what we're going to find is that we're really only going to potentially use, let's say A over sine of A equals C over sine of C. We might not even use the middle one, right? And that's not off limits, right? But what this formula is providing us is that we know that if you take the side length and you divide it by the sine of its corresponding angle, it's going to be equal to any of the other two side lengths divided by the sine of its corresponding angle. But we know that this is an equal, what's the word I'm looking for? These are equal ratios. With a side length divided by the sine of its angle. So let's try an example. So in this example, we're given a triangle. And this is actually from the textbook, a problem from the textbook, but we've got side lengths A, B, and C. Notice that they tell us what B is. B is going to be 10 miles. We know that angle A is 29 degrees. And we know that angle C is 53 degrees. But up here, we've got B. That was a really bad B. There we go. Because it's across from little b. And that is the angle B. Sorry, I'm losing my train of thought here. This is unscripted, I promise. So when we are given this situation, there's a number of things that we can do here. But first, we're going to try to solve for the side lengths. And I am given 29 degrees and 53 degrees. So let's try to find C. That was a really bad C. Let's try to find C first. So I always start with the unknown piece, right? So I don't know what C is, but I'm dividing it by the sine of angle C, which happens to be 53 degrees. And that's going to be equal to, now we should always pair it with a side and an angle that we know. And in this case, we know the side length B is 10 miles, but do we know what angle B is? We don't, but we can easily figure that out. So if we know that it's 29 degrees and 53 degrees, that is equal to 82 degrees. And we know that a triangle adds up to 180 degrees in total. So if I do 180 minus 82 degrees, that is going to give me a 98-degree angle. So angle B is no longer unknown. Angle B is now going to be 98 degrees. So we now can continue on with our law of sine example. So here we know that side length B is 10, and we're going to divide it by the sine of its angle, which is 98 degrees. Now, how in the heck do I solve for C, right? Remember, we're trying to find C. We want it to somehow be C equals blank, some number. And the nice thing is, in this case, I can switch over to my calculator and do some calculations here. I don't need to know what the sine of 53 is. I don't need to know what the sine of 98 degrees is. That is all something that we can figure out by just plugging it into our calculator. But how do I, if I just look at this side right here, how do I isolate the C? I'll give you a second to think about it. How do I isolate the variable C? Well, it's a fraction, so I need to get rid of the denominator. So I should probably multiply both sides by the sine of 53. So if I do that, I end up with sine of 53 degrees, and that's being multiplied by C divided by the sine of 53 degrees, and that is equal to 10 over the sine of 98 times the sine, I'm going to run out of room here. That's being multiplied by the sine of 53 degrees. We'll go from here, and we see that the sine of 53 cancels out here, and we're left with just C. So we are ending up with C equals 10 times the sine of 53 degrees divided by the sine of 98 degrees. And now I'm going to pull out my TI-83 calculator, and I'm just going to literally type this into my calculator, and it's going to give me my answer. So let me do that a second. Make sure your calculator is in degree mode, and you should be set. So 10 times the sine of 53. That gives me 7.986. We're going to divide that number by the sine of 98 degrees. And I get 8.0648. So 8.0648, we can round to 5. And now this is in miles. So I just solved for the, I just solved for C, and I discovered that C is equal to approximately 8.065 miles. Now, let's find angle A. Let's try to find angle A. So A divided by, what's across from A? Well, across from A is 29 degrees. So A divided by the sine 29 degrees, that is equal to 10 divided by the sine of 98 degrees. Because we know about we know what 10 is, and we know that this is 98 degrees. Now I'm going to multiply both sides by, what do I got to do again? If I want to try to isolate the A, I'm going to multiply both sides by sine of 29. And I'm going to kind of skip a step here. I'm going to kind of skip this step right here and just jump right to this last one. So we are going to end up with A equals, now remember, I multiplied both sides by the sine of 29 because that cancels it out on the left and just gives me A left over. So it's 10 times the sine of 29 degrees, all divided by the sine of 98 degrees. And once I calculate this piece in my calculator, I end up with A equals, and let me do that calculation in a minute. So I'm going to do 10 times the sine of 29. That gives me 4.848. And I'm going to divide it by the sine of 98. And I end up with 4.8957. I'm just going to round that to 4.9. So 4.9 miles. So A is equal to 4.9 miles. It's a little strange looking, hard to see. But anyways, you get the point. So 4.9 miles. Messy screen here, but we've got work here, and we've got some work there. I'll split up. Pause it if you need to check it over, rewind it if you need to go back, but that is how we solve for missing sides. Let's try on just a plain old triangle. So we're given a triangle ABC with angles 35 degrees, 135 degrees, and then they give us a side length of 80. So if I am trying to solve for A and B, well, I should always just try to figure out what is this missing angle. And in this case, we've got 135 and 35, and we know that that is equal to 170 degrees. Well, what's 180 minus 170? That is just going to be 10 degrees. So angle B is, it is 10 degrees. Hopefully you guys can see that okay. I'm going to get rid of that work because I will need this space, I'm sure. All right. How do I set this up? I want to give you guys a chance to think about this. How do I set this up? I'm trying to find, let's say we're starting with A. I'm trying to find A. How do I set it up using the law of sines? Some of you might guess, right? We always start with what we want to find out, right? We always start with our unknown. So we're going to start with A, divided by the sine of, what's across from A? Across from A is going to be big A, angle big A, right? They always correspond, so that's 35. So A, little a, is divided by the sine of 35 degrees. That's equivalent to, we always pick the angle and side pair that we know both of them of. do I know what side length B is and what the angle is? Well, I know that the angle is 10 degrees, but I don't know what the side length is. I know that angle C is 135 and its opposite side is 80. So let's use these two guys. So side length of 80 is divided by the sine of 135 degrees. Multiply both sides by our denominator, right? Multiply both sides by our denominator so that we are isolating A. So A is equal to that side length of 80 times the sine of 35 degrees, right? Because remember, I'm multiplying it by that guy, all divided by the sine of 135, which is what we had to begin with. Once I calculate this on my calculator, I end up with A equals, so let's do that in a minute. So 80 times sine of 35, that gives me 45.886. Divide that by the sine of 135. And that gives me 64.8927. So we're going to round that up to 9. So 64.9. We don't have a unit of measure here, so we're going to leave it the way it is. All right, now let's try to find B, right? We already found A, so we're good. But now we need to find B. So, right, with the law of sines, we always start with the missing side length. So B divided by, well, the angle across from it is angle 10, or angle B, but 10 degrees. So it's going to be B divided by the sine of 10 degrees. And that is equal to, let's use our known pair. Oops. We know 80 degrees and we know 135. So it's going to be 80 divided by 135 degrees. Now we're going to multiply both sides by the sine of 10, because when you multiply a fraction by its denominator, it eliminates the denominator altogether because you cancel out and you're just left with B. So we're going to get B equals 80 times, right now I'm multiplying it by sine of 10, so times the sine of 10, but all divided by, oops, I had this goofed. Some of you might be yelling, sine of 135. So all divided by the sine of 135. Now I need to calculate this in my calculator. And we get 80 times the sine of 10 is 13.89. Divide that by the sine of 135, and I get 19.646. So 19.646, so round that up to 6.5. And that is the missing side. Now, I know that this sounds like a lot, right? This is probably, it's all very new. It's hard when we're not in person. But with something like this, we just got to jump into it. And what it all goes back to is, right, this law of sines that's saying the side length divided by the sine of its corresponding angle is equal to another side length divided by the sine of its corresponding angle, etc. And now we'll come back to this on Thursday. But until then, go through my examples. Looks like a mess, but you can rewind, pause, whatever you need to do. Please ask questions on the Google Doc for office hours if you have confusion. You will be practicing this tomorrow on Delta Math. Thank you guys for tuning in.